Hi, we're going to take a look at an example of how you graph finding all the key characteristics for rational functions. Those characteristics include holes, x-intercepts, y-intercept, vertical asymptote, and horizontal asymptote. So we're going to go through the steps. Step number one is factoring the numerator and denominator, and that's going to help us find if there's any holes. See if any of the factors cancel. So step number one, I'll label my steps for you. You get x minus 2 times x minus 1, because negative 2 times negative 1 is 2. You add negative 2 and negative 1, it's negative 3. All over x minus 4, x minus 2. If we simplify, the x minus 2's divide out, and we're left with x minus 1 over x minus 4. We're going to come back to this equation quite a few times through the steps. Step number 2 says we got to find any holes, and those occur when factors cancel. So we have the x minus 2 and the x minus 2, so I set that equal to 0 to find the x coordinate. So the x coordinate would be 2, and to find the y coordinate, we plug it back in. So we plug it back into the equation that I have circled. 2 minus 1 over 2 minus 4, simplified, would get us 1 over negative 2. As a coordinate, this would be the point 2 comma negative 1/2. When we graph that, it's going to be represented like an open circle. So I'm going to note that right here because it's not technically a solution, even though it's part of the graph when you draw it in. So the open circle shows that it's everything else but that specific point. Now we're going to go ahead and take a look at how to find the x-intercept. And we set y equal to 0. Remember that f of x is the same thing as y. So we have y equals x minus 1 divided by x minus 4. So 0 is equal to x minus 1 divided by x minus 4. And we talked about earlier is you essentially just set the numerator equal to 0, because if we're going to be cross multiplying, then 0 times the denominator is always 0. So that's why it's 0 equals x minus 1. We add 1 to get 1. So the x coordinate, or the x-intercept, would be 1 comma 0. To solve for the y-intercept, we let x equal 0. Y equals 0 minus 1 over 0 minus 4. When we simplify, we get positive 1/4. The y-intercept would be 0 comma 1/4. The vertical asymptote comes from setting the denominator equal to 0. The denominator again was x minus 4 equals 0, so x is equal to 4. The horizontal asymptote comes from the degree. In our case, the degrees are equal. So the numerator degrees equal to the denominator degrees because they're both squared. Then that means we divide the leading coefficients. So you would get the coefficient of both numerator and denominator would be 1 over 1. So 1 divided by 1 is 1. So the equation would be y equals 1. So now we take all of these parts and we put them on our graph. Now we're going to take those features and graph them. We have our hole at 2 negative 1/2, so I put an open circle on the graph. The x-intercept is at 1, 0. Our y-intercept is at 0, 1/4. And now I'm going to go ahead and draw in the asymptotes using dotted lines in blue. So x is positive 4. I'd have my vertical asymptote through the point 4 on the x-axis. And y equals 1 would come right here above the y-axis. Remember, our graph has to not intersect with the asymptote. So see how I already have these 3 points over here? I can go ahead and draw in my graph, not through the hole, but right next to it. So there is one part of our graph, and now we need the other branch that's symmetrical to it. Notice that we don't have any points in that quadrant up here, so we're going to have to find some. And this is where our review of function notation is going to play a role again. Notice that I know I'm not going to have a point at 4, so I'm going to try to get at least 3 points, 5, 6, and 7. So I'm going to do f of 5, and I plug it into that original equation, which was x minus 1 over x minus 4. I'm going to write that over here. So it'd be x minus 1 over x minus 4. And this is what I plug it into. So I get 5 minus 1 over 5 minus 4, which simplifies to 4 over 1. So my coordinate point would be 5, because that was my x-coordinate, and my answer was 4. So I'm going to plot the point 5, 4. Now I'm going to do the same thing using f of 6. 6 minus 1 over 6 minus 4 would get me to 5/2. You can also make that as a decimal if you'd like, so that'd be 2.5. So the coordinate would be 6, comma 2.5. So 6, 2.5, and repeat the same thing for using coordinate 7. When we plug that in, we get 2, so our coordinate would be 7, 2. Notice that I have enough points now to get a general idea of what that second branch should look like. And that is pretty much the steps involved with graphing one rational function.